I'm Busi Manchu, the subject advisor of Physical Sciences and Technical Sciences and TMED. Today I'm going to do some of the admin to help Mr. Nambane. Mr. Nambane is going to be our paper 2 memo discussion person. He is going to help us with all the discussions. And colleagues, please mute. May please mute. Thank you, colleagues. Today, Mr. Nambane is going to do our paper 2 discussion. Please ensure that you have your question papers and memos with, so that you are able to be where he is at that present moment. And please do not mark when he is busy with the discussion, so that you can catch everything that we're discussing. When you have a question, kindly raise your hand and we will give you the time to raise your question and we can deal with it. And if we can't deal with it today or during the discussion, you'll definitely get the response from your subject advisors afterwards. So colleagues, kindly ensure that your mics are all muted so that there are no disturbances once we are busy with the discussion. The register for today's memo discussion will be sent to you via WhatsApp groups by your subject advisors, but we'll also try to put it in the chat today. But we urge the subject advisors to also distribute it via the WhatsApp platforms for those colleagues who will only be streaming in via YouTube. Otherwise, colleagues, have a great and a successful day. Mr. Nambane, when you are ready, you can continue.
Thank you very much, Mebusi. I should be ready. Let me just go up here. I believe we can start, colleagues. Thank you very much for attending this session of Grade 11 Paper 2 Memo Discussion. I just hope I am audible enough so that when I start now getting into the memo, we can all follow suit. So with indication that there are a lot of things that we had now to go through yesterday to modify the memo, such that each and every one of us can be now satisfied and also be in a position of ensuring that our learners get now the maximum marks now they deserve. So colleagues, without wasting any time, let me quickly go to question 1. So now with question 1, we only had, there's someone whose mic is on, so that person is somehow now disturbing me. I can't necessarily be talking while somebody else's mic is on. Thank you very much. So colleagues, what I wanted to say here is with question 1, we've received now queries on 1.2, 1.4 and 1.6. And maybe some of the queries we got were just now to emphasize or actually to understand how a specific option was chosen for this multiple choice. Thank you very much, colleagues. I hope I will no longer get disturbances. I tried now to remove mics from all of you, but unfortunately I cannot do that because as you need now to have that freedom of speech. So let me get straight into it. As I was saying, colleagues, with question 1, we only received queries on 1.2, 1.4 and 1.6. So I have a question paper here, but for the purpose of explanation, I will move now to the question paper so that you can easily see how and why when I start now explaining exactly how we got into the specific answer. So now let's check, colleagues, at 1.2. At 1.2, the question was the intermolecular forces now that we find, or forces between forces between the NH3 molecule in a liquid phase. Colleagues, all these forces that are here as indicated are all van der Waals forces. So now the challenge we received here was, if this is the case, then this option cannot be true. But now learners are now given an option to whether to choose between dipole-dipole, ion dipole, or London forces. So it cannot be London forces also, but now the problem in the memo is C was chosen as the correct answer. But when we check in detail, the only correct answer here can only be B, colleagues, because now we do not have an ion that is going to produce this ion dipole. So by so saying, it basically says in the memo, colleagues, the correct answer thereof should be B. So in your memo, quickly, let's go back to the memo, colleagues. At 1.2, the correct answer should be B. So that is one of the things that we decided now we need to change, because now the option given in the memo and in 1.2 does not necessarily give us the correct signs when it relates to the question that was given. So moving further on, the other one was at 1.4. Let's go now to 1.4. The correct option is still A at 1.4, but now maybe the question should be, how best can one explain exactly why A is the correct answer? Colleagues, let's go back to the question again and now check on 1.4. What is it that was asked, or what was it that was expected for learners now to answer? Let's read the question again, colleagues. The diagram below illustrates the change in potential energy of the reactions, and then we are given x2 plus 3y2 gives us now 2xy3. This is what we have here. So now, how much is delta H per mole of the xy3 that is formed? Colleagues, remember now, I'm going to write it here in a bullet form. The first thing that we have here, this reaction is exothermic, according to the graph that is given to us. Immediately thereafter, it says now when you check the graph, we have now minus 92 kilojoules that now decrease for every 2 moles. For every 2 moles produced. For every 2 moles produced of xy3. This is what now this graph is telling us in simple terms. So we have now 92 kilojoules decreasing for 2 moles of xy3 that is being produced. So what does this say? It says now the question is interested in per mole, basically 1 mole of delta H that is being produced now in terms of XY3. So when you check the system is giving us the 92 kilojoules. So for us to get per mole, it basically says now we need to be in a position of saying 92 minus divided now by 2. It will just give us the minus 46 kilojoules per mole. That is the reason why now here the correct answer becomes A. So with that being said, the explanation here of is that the question was interested in finding that for every 2 moles that is produced, we produce now negative 92 because of a reaction becoming an exothermic. So the mere fact that the reaction is exothermic, then it means our delta H should be negative, should be less than 0. Hence now the negative 92 of delta H from the graph, it's now for the production or for us to produce 2 moles of XY3. So producing the 2 moles, but the question was interested in now per mole. So basically the question was asking for only 1 mole of XY3. That is the reason why, colleagues, the correct answer here should be A. Hence we say even if you went through the paper and you did not understand why, the reason why we have a memo discussion is at 1.4 this is also 100% correct, as the answer is A. I did say now the other query here was at 1.6 that now how did we manage to get the D. So I will also go to the question paper again such that now we can be in a position of ensuring we understand why D was chosen, colleagues. Let me quickly move to 1.6, and here is 1.6. It should also be on your screen now. So with 1.6, it says now X gram of Mg reacts with 2x gram of HCl according to the following balanced chemical equation. Now, the information given is we are working with X, colleagues. So it basically says whatever mass of Mg is, the mass of HCl should be 2 times more, according now to this information that is given to us. But furthermore, what is it that the question is saying to us? The question is basically saying which one of the following statements is correct. Now let's check, colleagues. We try now to eliminate the 2 that is now completely incorrect. The chances of now X grams of H2 to be produced is very less. Hence, now the chance of A being correct is somehow not feasible for 1. 2 grams of Mg2Cl2 is formed. Also, the chances are not correct. So basically now, the only 2 options that we have here is for us to explain exactly which one between Mg and HCl is a limiting reactant. So the question here was focused and based on learners identifying a limiting reactant. But now there are few steps that we all know, colleagues, but I just want us to remind ourselves. The reason for that is I want us, when we get to a step of replacing the X with any value, we should be now in a position of saying definitely this is our limiting reactant. We usually say, colleagues, to these learners, they must calculate the number of moles. That is what we say. They must calculate the number of moles for each reactant. That is what we say, of each reactant. We usually say that. Now, immediately thereafter, we say they must now divide the number of moles with the coefficient of the reactant. That is now a system that makes it easy for them to determine which one is a limiting reactant. So they must just divide this number of moles with each of the coefficients of the reagent. And then lastly, we say now the one that gives you the smallest answer is your limiting reactant. So the smallest answer will be the limiting reagent. For the purpose of time, I'm just going to write it in this manner. So colleagues, how do we get this number of moles? Very easy. N of mg is just now x over 24,3, which is the molar mass, I believe. And n of HCl, which is just now 2x divided now by 36,5. Now here comes a tricky part or a challenging part. The challenging part here is now how do we eliminate the x? So eliminating the x, I'm just going to take a random number to say, let's focus maybe on saying we are working with a 2 grams of mg and we are also working with 4 grams now of HCl. So this basically says this will be 2 divided by 24,3, and this will be just be HCl, which will be 4 divided now by 36,5, and then you get that number. That number we divide, colleagues, with the coefficient, which is 1, and the coefficient here, which is 2, according to our steps. Then we find this side we are going to get 0,8, and this side we are only going to get 0,5. So what does this mean? It comes back now to where I said now the smallest number will give us our limiting reactant. So we calculated that for HCl, and now it basically says HCl should be our limiting reactant. So HCl, colleagues, it is now the correct answer, and according to our memo, the correct answer at 1.6 is D. I hope we are still following, colleagues. If there are questions, I will take questions immediately after question 1. So then those are a few of the queries we got. So it basically says, colleagues, I must just maybe emphasize that D is now 100% correct. From there off, all the answers remain the same, and all the answers remain the same. So it basically says we can quickly now go to question 2. So I am not sure, maybe see if there are any questions relating to question 1, or I should just maybe go straight into question 2.
At present, Mr. Nambane, I don't see any of the hands, colleagues.
Thank you very much.
So you can continue.
Thank you very much, Mebusi. Without wasting any time, colleagues, let me get straight into it. At 2.1, it says now CO2 is a molecule. Define what is a molecule, and we define a molecule as a group of 2 or more atoms covalently bonded, and that functions as a unit. So now here it says, colleagues, under the marking criteria, it says if any one of the underlined key phrases in the correct context is omitted, deduct 1 mark. This is also valid now for similar questions. So we did this every time when we have a definition. We are just going now to apply this marking criteria or the marking guideline for the emphasis of, even if the learner now omits any phrase, but now the context is still correct, that learner should at least now be awarded a mark, because we did consider that now these learners are now writing their final paper. So the key critical thing was how best can we be able to assist them. So that is the reason why we tried now to relax the marking in a sense that we also have part marking. So there's 1 mark now for just saying 2 or more atoms covalently bonded, and that functions as a unit. So now at 2.12, it says draw a Lewis structure of this molecule. So it is a carbon dioxide, colleagues. So carbon dioxide has a linear shape. So what we look for here, it must be our octet rule. It basically says we need now to ensure that the double bond between the carbon and each oxygen atom is there. Then we can award a mark. Two oxygen atoms of each two lone pair of electrons. So by so doing also, we just now check the oxygen to have now two lone pairs. But remember, colleagues, also emphasize the issue that each of the oxygens must now have that maximum of 8 electrons around it. So key thing also, focus now on checking if now we do have a maximum of 8. Then 2.13, what is the molecular shape of this molecule, which is carbon dioxide? It is linear. And now at 2.14, calculate the difference in the electronegativity of carbon and oxygen. Colleagues, just be aware this is a calculation, but now we only awarded 1 mark now for the final answer. So we only awarded now only 1 mark for the final answer. So be on the lookout for that. Usually people we give a mark for the substitution and a mark now for the final answer. In this instance, we only now award a mark for the final answer. And then at 2.15, is the carbon dioxide molecule polar or non-polar? And the correct answer here, colleagues, it's non-polar, just for 1 mark. So these ones, I believe they are basic and they are straightforward. Now with question 2.2, that is where now other queries came from, to say now some of the letters were unclear in terms of the positioning, and some of the explanations thereof were somehow not clear as to what is it that we are asking. So let's get straight into the question, colleagues. It says here, the graph shows the changes in potential energy as the function of the distance between the nuclei of 2 hydrogen atoms during the formation of H2 molecule. So the graph is given, but now when the graph is given, colleagues, let's just get into it. I have my question paper here. I will also try to show it to you such that we can easily now follow through in terms of how to go about this one. Colleagues, let's just first try to understand this graph. Let's just quickly try to understand this graph. The intention here was, look where S is. S now is actually a measure from 0 to T. That is what that S basically means. So when we focus on S, S now should give us our bond length. But now check, once a learner has decided that now from 0 to T is the bond length, the only distance now that we have, which is TS in this instance, so the TS will give us our bond energy. So because of that, there isn't much of the confusion, colleagues, that we need to consider, because now the S, it's not sitting at the apex of this particular graph. It is only saying it is the distance now between 0 and T. So there isn't any way, colleagues, where we can say, but now these learners are going to confuse T, and S, because if we wanted now to focus on T and S, we could have placed the S now just next to where we have the apex, where the graph now is changing to R. So because of that, colleagues, there wasn't any much of a confusion that relates to this specific question, because let's read now the 2.1. The 2.1 reads as, give the name of the physical quantity represented by S. So from the explanation, obviously it is from 0 to T, but now the letter is not at T, colleagues. The letter is the S because it is now indicating that distance between 0 and T. Hence, the correct answer here, colleagues, should be just bond length. Now, which letter represents the formation of most stable molecule? Colleagues, here the answer says it must be T or S. We went into a discussion in terms of this question, as much as I explained now how the graph works. When a learner decides to choose, the correct answer should be T. But when the learner decides to choose S, we will also award. The reason is, like we said, now S should have actually been placed now where the graph starts now to curve. So if we decide now to accept S like as we did, it is only a matter of the positioning of S in this instance for 2.2.2. It should have been there at the apex, then it can be either T or S. So be on the lookout for that. So we award, colleagues. That was our way of saying, let's reward now these learners maybe that are going to choose S for this purpose. So is the bond formation exothermic or endothermic? That is now at 2.23. Give a reason for your answer. Give a reason for your answer. So the answer is exothermic, and note, colleagues, there isn't now any negative marking, so no negative marking. So if we do not have negative marking, colleagues, it basically says if the learner decides now to choose endothermic and gives now correct reasoning, we will still award a mark, colleagues. So the correct answer here is exothermic. One of the options there says, as the molecules move closer to each other, the potential energy decreases or energy is released when the bonds are being formed. So colleagues, now just check, we do not have negative marking on this one. At 224, how does the potential energy change from T to S? Choose increase, decrease, or remain the same, and give a reason for your answer. So the correct answer here, colleagues, it's increases. And now for that matter, it says now forces of repulsion increases. It can be any other option, colleagues, that now says we have now a force of attraction that is now being increased. So we can basically add maybe such keywords as forces of repulsions are greater, forces of repulsions are bigger. So these are just keywords that basically just emphasizes that we did have now an increase in forces of repulsion. So all these words are just words that says the forces of repulsion actually increased, colleagues. They become greater, they become bigger. So let's now look for those key critical words, because now our learners will not necessarily give the exact words that have been used in the memo. So once they just say everything that indicates that the forces of repulsion were actually increasing, it is correct for us, colleagues, to award that mark. Also, no negative marking on this one, colleagues. No negative marking, so you just now mark each bullet independently. So now that is basically it, colleagues, with question 2. Maybe we'll see, I will just have to check with you. Like I said, once I am done with a question, I will come back to you just to check if we do have any questions from the colleagues.
Okay, thank you, Dr. Nambane. There's no question at present, but can you kindly go back to question 2.1? The definition.
2.1. 2.1.1.
That the definition that I'm not
Yes.
sure which the number is. Yes.
I am there, Mebusi.
Okay, thank you. Colleagues, when we're talking about the notes that we get every time when we have the marking guidelines, when it says if any one of the underlined key phrases in a correct context is omitted, deduct 1 mark. We are trying to make sure that our questions, whether it's grade 10 or grade 11 or grade 12, they are on the same path. This is the way now we now mark in grade 12 for the final papers. So we need to ensure that our papers also align themselves with the national papers. So when we talk about the key phrases, colleagues, kindly ensure that you concentrate on the underlined words. For example, the first one, you check whether it says 2 or more atoms covalently bonded. So anything missing there, the first mark is gone. And then the second mark functions as a unit. So anything missing there is the second mark. So just concentrate on the underlined words, please. And that will be what we do with basically all the definitions. Thank you, Nkosi.
Thank you very much, Mebusi.
There's a hand here.
Okay.
Yes, it's Alta Fourie. I just want to ask something. Instead of talking at 2.2.4 of forces of repulsion, the learner says the repulsion energy increases. Can we accept that? Going to
Energy of repulsion.
The energy of repulsion increases.
I believe we can accept Mebusi.
Yes, let's accept, but colleagues, it's important to encourage the correct
Science.
wording because it's actually a force, not energy. But let's accept because repulsion is there.
Okay. So thank you very much. Alta, then it means the emphasis on repulsion, which will be the indication of a force, should definitely be there. But the emphasis now, when we go back and maybe reteach these concepts, the emphasis now should be on the force, not necessarily the energy thereof. So colleagues, without wasting any time, let me quickly go to question 3. And now at 3.1, the question says define the term vapor pressure. And the stem of the question was the graph below shows the vapor pressure of HCl and HF at different temperatures, and the graph was given. So define the term vapor pressure for 2 marks. So colleagues, remember here it says now it is a 2 or 0, but now I found it now not necessarily comprehending with what we said as the marking criteria, and then we said this is also valid for similar questions. So now when we get to this one, colleagues, also let's apply that marking criteria even though it says it is a 2 or 0. For us just to be lenient, let's just now try to apply that marking criteria of 2.1, where it says if any of the underlined key phrases in the correct context is omitted, deduct 1 mark. This is also valid for similar questions. So it basically says this can be a 2 or 0, yes, but the critical thing, because we are now trying to be lenient to support these learners the best possible way we can, the first thing will be to check if all the underlined words are there. If one of the key words is not there, colleagues, now we can apply that marking criteria where we say now if one of the keywords is omitted, a learner should at least get 1/2. So this is the definition here. It says now the pressure exerted by vapor at equilibrium with its liquid in a closed system, and then that becomes now 2 marks. At 3.1.2, which compound, HCl or HF, has a higher boiling point? So the intention here was to ask for the interpretation of the graph and the relationship also in terms of the boiling point and the vapor pressure. So the correct answer there, colleagues, was just HF for 1 mark. Now question 3.13 says explain the difference in the vapor pressure between HCl and HF. So colleagues, the first thing or the first mark is awarded if a learner says now between the HF molecules we have hydrogen bonds. So any indication that we have hydrogen bond, 1 mark should be given. Between the HCl molecules, we have now dipole-dipole. That is now another mark. So now be on the lookout here, colleagues, where we say now any of this 1, 2, 3, 4 options can now make it to be that 4 marks that we are looking for. The 3 mark here, it's now for the intermolecular forces between HF molecules are stronger than those between HCl. So we need now that comparison in terms of the strength of the intermolecular forces. So HF molecules are stronger than those or between HCl molecules, or hydrogen bonds are stronger than dipole-dipole as the same option, colleagues, that will give us the 3 mark. The intermolecular forces between HCl molecules are weaker than those of HF molecules. So this means, colleagues, all these options here, they are actually options that gives us now that 3 mark that we are looking for. But the last mark, which will give us the 4th mark, because this was out of 4, should come now in comparing the energy, or actually stating which now molecule will have higher or more or less energy thereof. So it says here more energy is needed to overcome the intermolecular forces between HF molecules, or now less energy is needed to overcome the intermolecular forces between HCl. So this is the pattern, colleagues, that we are used to, but we just now compressed everything such that we can be in a position of fully explaining how everything should be answered. So just check, it can be especially bullet number 2 and bullet number 3 and number 4, where we have now different options of what is it that our learners can write or actually say in their answers. So now the last one is this one, where we compare the energy. So more energy is needed to overcome the intermolecular forces between HF molecules. Colleagues, now if this learner says more energy is needed to overcome the intermolecular forces without specifying for which organic molecule, we do not award a mark. We need now to be in a position of saying the learner must commit to say which energy or which molecule actually needs this more energy. So if the learner omits the keyword now of which molecule, so we need them to specify, especially for where they now say which energy or which molecule is going to need that more or less energy. So it's important, colleagues, such that now they need to specify. So moving on to question 3.2.
Sorry, Nkosi, can I come in there?
Come in, Mebusi.
Nkosi, colleagues, in that question, please, in that last bullet, ensure that learners write intermolecular forces, to overcome intermolecular forces. If they say to overcome bonds, no mark must be given. We need to ensure that they know it now in grade 11, because we never accept it in grade 12. So remember, when you're talking about bonds, we are talking about interatomic forces. So they need to say to overcome intermolecular forces, not bonds. Thank you. Thank you, Nkosi.
Thank you very much, Mebusi. Colleagues, that is 100% correct, because the misconception here has always been that more energy needed to break the bonds. So we no longer accept that. It should be more energy is needed to overcome the intermolecular forces. Thank you very much, Mebusi, for that. I nearly forgot it. And let's move then, colleagues, to 3.21. So at 3.21, it's another definition. Define the term melting point. So melting point, colleagues, is defined as the temperature at which the solid and the liquid phases of a substance are at equilibrium. So this basically says, colleagues, we need now remember to apply that rule or that marking criteria in 2.1, which says now if one of the keywords, underlined keywords, is omitted, but everything is in the right context, then we should be able to give that learner at least 1 mark. So even here, even if it says 2 or 0, just remember now to apply that marking criteria. So if any of the keywords is omitted, kindly just apply the marking criteria that we said. Now that should be valid for all similar questions, which will be in most cases our definitions. Now, which letter, A or B, represents HBr? So the correct answer is B. Explain the difference in melting points of HCl and HI. Colleagues, when you checked your memo, there was an inclusion now of HBr, but the question did not necessarily want learners to explain in relation to HBr. But our point of reference here was, if the learner now knows that B is HBr, some learners can also now compare HCl with HBr, which will still be in relation to same principle as explaining HCl with HI. So that is the reason why we said let's include the HBr if a learner decides now that I am 100% confident in order for me to explain in terms of HBr and HCl, or even compare HBr with HI. That is the reason why, colleagues, if you check, actually we tried now to complete the reasoning by including all three. That is now HI, HBr, and HCl, such that we can broaden now the scope of the reasoning in terms of what learners are going to say. So, but I doubt that you are going to get such an approach, because the key critical thing is they were told now to explain the difference in melting points between HCl and HI. So anything in the memo stays the same. It's just that now if they decide to have HBr somewhere, then you just need to check if that HBr it's placed in the right context. It's placed in such a way that it makes sense in terms of the science. So now let's look into it. It says now explain the difference in melting point of HCl and HI for 3 marks. So 1 mark, colleagues, is here where we say HI has a larger molecular mass or size than HBr and HCl. And by also saying HCl has a smaller molecular mass than HBr. So colleagues, here, even if the learner just now compares HCl and HBr, that will be HCl and HI, that will be correct. For one, just to say it looks like my internet is giving me a problem, but am I still audible, colleagues? Colleagues, sorry about that. It was just a bad connection from my side. But I believe I am back. If you hear me, then let's just communicate, and I'm going to share my screen again.
I think you have to share your screen again, Nambi.
I'm going to do so, ma'am. Thank you very much. It was just a bad internet connection. Sorry. Okay, I believe I am back, colleagues.
Yes, you are, Daddy. You are.
Thank you very much, colleagues. Sorry about that. It's actually load shedding this side, so yeah. But then I had a backup, so sorry about that. We can now go straight into it, colleagues. I was at 3.2, where the question now was explain the difference in the melting points of HCl and HI. It's when I explained, colleagues, that we just now decided to add the issue of HBr just only to expand now the reasoning for these learners. But I doubt they are going to consider that, because the question was straightforward to say now focus only on HCl and HI. So HI has a larger molecular mass or size than HCl. That can also be accepted, colleagues. Or even if the learner says now HCl has a smaller molecular mass than HBr, we will still accept, colleagues. So it basically says bullet 1 is the comparison in terms of the molecular mass and the size of HCl and HI. Bullet number 2, colleagues, says now the intermolecular forces between HI molecules are stronger than those of HBr, but the intermolecular forces between HCl molecules are weaker than those of HBr molecules. So basically, in simple terms here, a learner can only just now focus on HCl and say HI molecules are stronger than the intermolecular forces between HCl. They do not need to specify, colleagues. The emphasis is on the strength, whether they compare in terms of strong or weak, depending on which one the learner is going to start with. We can easily accept that also, colleagues. So because of that, now it takes us to bullet number 3, where they need to compare the energy. And I'm going to now emphasize again what Mebusi said, to say they should now, colleagues, emphasize the issue of more energy is needed to overcome the intermolecular forces of HI molecules compared now to that of HCl, or in this instance of HBr. But less energy is needed to overcome the intermolecular forces between HCl molecules compared now to HBr. So it will still be 3 marks, colleagues. Let's just check what is it that this learner is comparing. So if the learner compares HCl with HBr, we can also consider that with the fact that everything is in the right science, colleagues. We can only award if these learners now give us the information as now expected here. So that is the 3 marks of question 3.2.3, and the total mark for this question was now 13 marks. Mebusi, allow me to ask you to check if we do have questions relating now to question 3.
Yes, we do have questions. I just want to talk to Mr. Mutupi. Kindly switch off your your video so that we can have, there's many of us, so the connection can still be okay. So kindly switch off your video, please. There was a question from Aleta, Mr. Nambane. I don't know whether you got it. She was asking do we accept if the learner explain in terms of electron cloud? Aleta, I don't know whether you want to come in again.
Aleta?
Just unmute, please.
There we go. They didn't want to unmute. Yes, the learners refer to compare the electron cloud density of the one molecule to the other one, and then just states which one has the greater density and therefore has stronger forces. Maybe accept that.
That is now at 3.2.3.
3.2.3, yes.
Okay. Kindly study it afresh such that we can follow now if there's part marking in terms of each bullet has been covered, or which bullet are you specifically referring to?
I'm referring to the first bullet. So instead of referring to the size of the molecule, they refer to the electron cloud density around the molecule.
And now they will just say HI has now a greater electron density than HBr or HCl.
Yes, and then they continue with therefore their stronger forces. So the rest is fine.
Okay. Mebusi, kindly come in, because now from what I know, our CAPS document says now it should only be molecular mass, size, the type of intermolecular forces. Maybe you should now come in with your expertise if the issue of electron density is now part of our syllabi or the curriculum thereof.
Let's think about it first, because also, yes, at the end of the day, that electron density will contribute to the molecular size.
Molecular size.
But it is important for the learner, yes, but it is important for the learner to go as far as molecular size, because the mark is there on the molecular size or the molecular mass, not on the electron cloud. Actually, the electron cloud is a way of us trying to explain to the learners, but it's not part of the scope for the high school learners as such. So it is important for them to go as far as molecular mass and molecular size. So let us not accept it.
Yes.
But it is correct. So can I award it to them?
Aleta, can I say do not award, because now the critical thing here is we will be creating a misconception of saying that now should be correct. Remember, this is one of the topics that overlaps to grade 12. So if they move now with the issue of electron density or electron cloud, it's now creating that this is the correct way of saying it, whereas we are interested in actual the molecular mass or even the size of the molecule. So for now, I will say let's penalize for the emphasis of us now going back and recorrecting whatever we said now to these learners, because it is not even in our scope. So it makes it a little bit complex to accept, because if you accept now, you are basically saying it is the correct thing to do. So for me, I will say do not give for bullet number 1, but now give for bullet number 2 and number 3. Such that
okay, Nkosi.
Yes.
Okay, Nkosi, let me come in.
Come in,
because the scripts are not going back to the are not going back to the learners, and I want to believe that's something that I, as a teacher, talked to the learners about. So we can award that mark for now, but Aleta, just kindly ensure that for next year you emphasize the part of the molecular size or the molecular mass.
Okay, thank you.
That's the reason why I have you here, Mebusi, because at times I know you always say I'm too critical and difficult to understand. So maybe that's the reason why I have you here to assist in terms of running this operation of the memo discussion. So Aleta, then it basically says Mebusi says we can award. Then let's award. I honestly do not have a problem because it's going to be a few learners maybe that say that. I believe so, Mebusi.
Yes, and Nambane, we also had a hand from Motel at some point, but it's no longer there. I'm not sure whether they still want to come in or not.
Okay.
Motel Science?
I believe they will raise their hand again, Mebusi, if they want to say something.
Yes, that let us continue.
Thank you very much. Colleagues, we are now at question number 4. And at question number 4, the graph on the right shows now the behavior of an ideal gas and a real gas at different pressures. 4.1.1, write down 3 properties of an ideal gas. And the one is that now it can be any 3. We've given you a maximum of 4. The particles occupy no volume. That is now a mark. And the particles exert no intermolecular forces on one another. The particles are identical. The collision between the particles and the sides of the container are perfectly elastic. So colleagues, the emphasis here is on any 3 that the learner can give. So like I usually say, the phrasing of the learners will always differ, but if it's something that sounds similar or produces that similarity in terms of the bullets that are here, let's award our learners the given marks, colleagues. Then it further moves on to say now, under what conditions will a real gas behave like an ideal gas? This is now at low pressure and high pressure, and then that is 2 marks for 4.2.2. So there wasn't anything complex about this question. It was just that the learners had to give those 2 conditions. At 4.3, which graph M or N represents the real gas? Like colleagues, we did say the interpretation of graphs is always a challenge. Maybe that is the reason why you, especially in paper 2, that is the reason why when you check, it is mostly graphs and graphs. This is the reason why we wanted now to try and address all the challenges of interpretation of graphs, because this skill of interpreting the graphs is a skill that our learners need now throughout. So the question was basically intended to check if the learners are able to know how will a real gas behave compared now to an ideal gas. So the correct letter there is M, and then they say now fully explain your answer to question 4.3 by referring to the pressure only. It says, colleagues, by referring to the pressure only. So if the learner says anything that is temperature related, we do not award any mark. So because of that, colleagues, the emphasis should be pressure. So here on the memo at 4.4, it says now at high pressure, the gas is compressed to a smaller volume. The amount of space between the molecules of the real gas is smaller than that of the ideal gas. And then we have more collisions takes place and pressure exerted by the real molecules is higher than predicted for an ideal gas. So colleagues, for bullet number 2, or let's say bullet number 3, because this one will be bullet number 1, number 2, and this will be our number 3. So for bullet number 1, colleagues, instead of a learner saying at high pressure the gas is compressed to a smaller volume, we can also accept that at high pressure the gas liquefies. So we can add that issue to say now at high pressure gas liquefies. We can also accept that that option here to say it liquefies. So we can accept that. Now the amount of space between the molecules of real gas is smaller than that of an ideal gas. It stays as it is, and then it says now more collisions take place and the pressure exerted by real gas molecules is higher. So there was another option where it says each molecule does not have a zero volume. That basically says that small volume, so it's still the same thing, and now it plays a role now in the volume of the gas. So this is an option that I was sent last night, but now I'm only writing it down just to check if all the bullets are there. So this learner who wrote now such a reason for 4.4 will only get a mark for saying at high pressure a gas now liquefies, because they do not have anything that says about the space now between the molecules of a real gas and the ideal gas. They do not now say anything in terms of the collisions of the real gas. And now that will give us 3 marks, colleagues. And then at 4.5 for 2 marks, what conclusion can be drawn about the relationship between pressure and volume of an ideal gas? Give your answer with the help of symbols. So we're only asking here for learners to explain the relationship between pressure and volume. So somebody asked me to say, but now what if we have a learner who decides to write something like PV is equals to K? And I said we cannot award a mark now, because if K is going to represent a physical quantity that is a constant, in this instance we're only interested in checking if learners really understand that how the ideal gas behaves compared to a real gas. Once we include now PV is equals to K, it basically says it is forcing us to specify basically which law are we referring to. Are we referring to Boyle's law? Are we referring to an ideal gas law? So hence we cannot accept this particular option, colleagues. The reason being, once you include a constant, then it becomes a law, whereas the question only focused on the emphasis of the relationship between pressure and volume. So if the learner wrote PV is equals to K, colleagues, let's not award a mark, because now the K, remember, it is going to be a constant. If it's a constant, then it relates now to a law. It's either ideal gas law, PV is equals to nRT. It's now either your Boyle's law, whereas now the agreement is those two sections do no longer form part, especially in this year, in terms of us dealing with any of the laws. So the emphasis here was on the relationship between pressure and volume. And the total of the question here is 11 marks. So Mebusi, I am done with question 4. If there are any questions, kindly check for us.
4.1.
4.1.
Yes, the question says, what if a learner in the first bullet says particles are equal in size?
Particles are equal
In the
in
first
size.
bullet, particles are equal in size.
Particles are equal.
Is it 4.1? Bullet
Yeah,
3,
yeah.
sorry, not bullet 3, for bullet 3.
Bullet
Particles are
3,
equal in size.
bullet 3 of 4.1.
Yes,
Okay, where it says now the particles are identical.
are identical.
Yes.
Yes.
So the mere fact that they are identical, it basically says they have the equal equal size. So I believe we should give Mebus. So particles are equal in size. Particles are identical. I think we can give Mebus.
Thank you, Tate. I agree.
Thank you very much.
I don't see any other question, so I believe you can continue.
Thank you very much. And now, colleagues, if there are no questions on question 4, let's quickly go to question 5. And now, question 5, colleagues, it was somehow different from what our learners are used to in terms of endothermic or exothermic, but we intended in testing the practical skill a little bit of these learners now understanding how things are being done here. But I believe they will do well only if they are in a position of knowing how to differentiate between exothermic and endothermic. So it says here at 5.1, a group of learners dissolved 2 different compounds in water to classify the reactions as exothermic or endothermic. They used apparatus below and observed differences in thermometer readings. And then we have our experiment 1 where they used now NH4 and O3. And then we have experiment number 2 where they used NH4OH. In experiment 1, the temperature dropped from the initial reading of the thermometer, while in experiment 2, the temperature rose from its initial reading. So now 5.1.1, consider the above mentioned information and write down an independent variable. So remember, colleagues, independent variable is the one that now we are able to change, the one that we have control over. So it's basically the substances that we are going to use to perform this experiment, either the chemicals that we are going to use to perform this experiment, or also the learner can basically just say NH4NO3, and the emphasis, colleagues, here should be on the end to say it must be 2 of them. If they specify to say it is NH4 and NO3, they must now specify both of them, is then that we can award a mark. That is now a critical thing that I wanted us to check. But if this learner just says substances, we give a mark. If they just say chemicals, we will give a mark. But if the learner says now NH4 only, no mark. It should be NH4 together now with NH4OH. The issue of now being dissolved in water to become a solution that we can ignore because now it is included in the brackets. So dependent variable, it is now the type of reaction, either exothermic or endothermic, because it's what we want to test. And then the other one here will be the influence on temperature. So colleagues, even if the learner just says temperature, just award a mark for that. So controlled variable, the initial temperature of the water, because remember, we are going to use the same amount of water to create these solutions. So we must try that now we control the temperature of that water in order for us to create this solution. So the correct answer here should be the initial temperature of water. But I believe and think that most learners will say water only. So if they say water only, colleagues also award a mark, because now it will be most the same water in that specific environment of the laboratory. So even if they do not write the initial temperature of water, if the learner just says water, you can easily award a mark. At 5.1.2, which experiment 1 or 2 represents an endothermic reaction? So we gave them colleagues that in experiment 1, the temperature dropped, while in experiment 2, the temperature rose. So it was just an issue of basically knowing what is happening in terms of endothermic and exothermic, especially the formation of the reactions thereof. So because now experiment 1 dropped in terms of temperature, it basically says the energy was absorbed. So once the energy is absorbed, it basically says that reaction must be an endothermic reaction. So the correct answer is experiment 1. No negative marking, I must emphasize, colleagues. And then energy is absorbed. So I must emphasize no negative marking on this one also, colleagues. The temperature drops. And then we move now to 5 point.
Mr. Nambane,
Hello,
there's a question
Mebusi.
from Moteo. Please.
Thank you.
Nkosi, yes, I have a question about 5.1.1. The learner writes there for the first option, where for the substances or chemicals, he just says the solute in water, implying the different solutes.
Solute in water.
Yeah.
Solute.
And then for the second part, let me finish all of them that you can decide. The second part just says the temperature.
Which is
And
now bullet number B.
At number B, just says not the influence on temperature, but the temperature. And then for the last one, for the independent variable, time. Now, I assume when the temperature was measured, it was taken at specific times. So I don't know if this child is thinking of that and whether it can be accepted. I'm going to mute so you can decide and talk back.
Before you leave, Alta, maybe I should check at C, where now the question was controlled variable. The learner wrote time. Okay, I see it now, Alta. The learner wrote time now for C. The learner wrote time. Okay, let me quickly answer A. Solute in water. It's fine because now remember these chemicals were going to be dissolved in water. So solid in water, we can accept alta because NH4, NO3 and NH4 that becomes our solid that were dissolved in water. So we can accept that. For B, alta, I did emphasize that even if the learner just says temperature, we can award a mark. Hence, I did now highlight it. And then at C, the answer there is temperature. But now the issue of time to specify as a controlled variable, maybe see, I will need you to chip in here. Time as a controlled variable to say we are measuring them at a specific time interval such that we can have now the reading of this temperatures, and immediately after that we can stop our time and have our readings thereof. So I am not sure how to go about that, but it's one of the options maybe that we can discuss.
Let's discuss it after this, and then we'll give it to the teachers via the WhatsApp group.
I believe so also. Alta, we will look into it and discuss. If it happens that we have an errata, maybe we will add it into this memo immediately after we have discussed with Mebusi. Thank you very much, colleagues, with your inputs. And
there's another question. I think it's Taitani.
Okay.
Good morning, Mr. Nambane and Mebusi.
Hello, Tati Taitan.
For bullet C, if a learner wrote the mass of solute in water, and then the mass, that's the first one. Then the second one, and then learner says the initial volume of water.
Initial volume of water. Thank you, Ntate Taitsan. Mebusi, I think these two also will also consider them and return to the colleagues with that, so that we do not now take quick
Yes,
decisions. So Ntate Taitsani, we will consider them, and if we come up with a decision, definitely your subject advisors will distribute this information to you. Thank you very much, Ntate Taitsani, for that. Colleagues, now we are at 5 point. If there are no
There's
questions,
a question
Mekuni.
again from Mr. Mutupi.
Okay.
Mr. Mutupi, fire away. Nkosi, the hand is lowered, so maybe it was a mistake. I think you can continue.
Okay, thank you very much, Mebus. Then, colleagues, we are at 5.2. The graph of the potential energy versus the cost of the reaction for a certain chemical reaction is shown below. And the graph was there. Write down a letter that represents the activation energy, and the letter was Z. And now write down the letter that represents the delta H. The letter there was just Y. And then the calculation that came, it's a calculation on the activation energy, and the values were given there, colleagues. It says calculate now the activation energy. So this is just now reading from the graph where Z is, and this was just 250 minus the 25, and then the answer there became 225. So maybe we should just emphasize, colleagues, that we must always have the correct SI unit. For us to award this mark, the final mark, it should be with the correct SI unit, because now most learners, I think they will omit this SI unit. So kindly check for it and be in a position now to allow to give a tick for that one. So this was question 5, colleagues, and question 5 was out of 9 marks. We discussed it in detail. I don't think there will be any questions now because of we did try to attend to the questions we had. So without wasting any time, I will quickly go to question 6. So at question 6, colleagues, 6.1 is a definition. Remember that marking criteria applies now for everything. So it basically says all the definitions, we are going to mark them the same way. And then it's the question read something like 25 grams of impure sample of calcium carbonate. Calcium carbonate reacts with excess hydrochloric acid, HCl, of the concentration of 1,5 centimeter cubed. The balanced chemical equation for the reaction is given. And then at 6.1, it says now state the Avogadro's law in words. So 1 mole of any gas occupies the same volume at the same temperature and pressure. So like we said, colleagues, even if it says 2 or 0, let's quickly go back now to that marking criteria in 2.1.1 to just emphasize and check if any of one of the keywords has been omitted. Then we can award a 1 mark if everything now is in the correct context. So that is now 6.1 for 2 marks. And then we have 6.2.2. 6.2.2, which substance is a limiting reagent? Colleagues, they were told that HCl is in excess, so this should be an easy mark for all these learners. So they can either write it in terms of calcium carbonate molecular formula, or just in words, calcium carbonate. Then colleagues, there's 6.3. At 6.3, it says the percentage purity of calcium carbonate is 83%. Calculate now the volume of carbon dioxide that is produced if the molar gas volume is 24,000 centimeter cubed. So this part, colleagues, is the stoichiometric calculation. So for both options that we have, which is option 1 and option 2, we have now the bullets that you need to follow, the marking criteria that will assist you to ensure that the marking runs smooth, to ensure that you basically look in terms of where and how can these learners now be able to get the maximum marks. So remember, colleagues, the 83% that was given, it's the percentage purity, but now we are working with an impure copper. Sorry, not an impure copper, but an impure calcium carbonate. So what does this say to us? It says only the pure calcium carbonate will take part in the reaction. That is what now the science is saying. If that is how we approach this, learners are expected now to first calculate the mass of the pure copper they have. So the critical thing here was they must know that now in an impure substance, the only substance that are actually taking part in the reaction are the pure particles, or the pure sample in that matter. So it says here now, for one to award the first mark must be calculating the mass of the impure. That is now 83 divided by 100 multiplied by 25. So the learners can also say 83 divided by 100, which will give them something like 0.83. Then they multiply by 25. It doesn't really matter, colleagues, as long as the indication is that they have now multiplied that percentage with the 25. And then here it says at bullet number 2, it is just now the formula mark for M is equals to Mn. So I will just like to emphasize that the learners, mostly we encourage them to write M over M, so you can also award a mark for that. And then now substituting the M and the M, which is now the molecular mass, into that specific equation. But when we go through the options, colleagues, everything will sit well. And then the other mark, which is now mark number 4, it is at the molar ratio. And this molar ratio, I think, according to the information that is given from the formula, from the balanced chemical equation, is just 1:2. Sorry, it's 1:1, because we are now focusing on the carbon dioxide. It's just 1:1. So that is the mole ratio thereof. And then just substitute now the number of moles, and colleagues, it's important, and 24,000 centimeter cubed or 24 decimeter cubed in this equation. So for us to award this 5th mark, it must be the substitution of the number of moles together with the molar volume of a gas. By so doing, then we are in a position of actually giving that mark if the substitution happens in the equation of N is equals to V over Vm. So let's move again, colleagues, to option number 1. Option number 1, for the first mark, it is where the learners now calculate the mass of pure calcium carbonate in the impure sample of 25. So the mass was given there or calculated as 20.75 grams. So remember, the mark is for bullet number 1. So you usually say, let's assign letters A, B, C, such that you can maybe have that chronological order in terms of how to award the mark. Now, calculating the number of moles, remember it's 1 mark for the formula and then 1 mark of substituting the molar mass of 100 in this specific formula. So the other mark, it's sitting for substitution here, and the other mark now it's for the formula there. Further move on, this mark here, it's for the ratio. And now remember, we said, colleagues, this must now be the number of moles together with the number of the molar volume of a gas. Is then that we can award that mark of number 5. Then the final answer can either be in decimeter cubed or centimeter cubed. Just check what is it that now the learner wrote. So that is now, colleagues, option number 1. So with option number 2, colleagues, the learner works with impure calcium carbonate and calculate now the number of moles, because remember, most of our learners, when they see mass, they automatically think the number of moles. So this option came about saying, but the mass is already given of an impure, which is now the 25 grams. So the learner calculates now the number of moles of impure calcium carbonate. So if this is the number of moles of impure calcium carbonate, what will be now the number of moles of pure calcium carbonate? It is just now that 83 divided by 100 multiplied by 0.25. Then this will give us now the number of moles of calcium carbonate. So now that we have the number of moles of calcium carbonate, colleagues, it basically says from this we can easily now move into this section here, because now the other mark will be for the ratio, the substitution now of the number of moles with the molar volume and the final answer. Hence we said, let's not retype everything, but now this here, whatever comes after in option 2, will definitely relate to what is in option number 1. So I believe they will do well in this question, which is 6.3, and the marking criteria is definitely clear and straightforward, colleagues. And now the last question,
Nkosi, can I come in?
Alome Kamini Mebusi.
Kindly explain the arrows that are in the options, Nkosi, for the sake of our novice markers.
Okay. The arrows, colleagues, are just here for the emphasis of the previous answer has been now taken to the next following step, such that now even if now it basically says the learner got this answer incorrect, you continue marking with the mistake now that the learner did. It basically says you continue checking if the answer that the learner got is the same answer that the learner is using. That is what the arrows basically indicate for the purpose of marking. So it basically says if the learner now gets this information here of calculating the mass of impure incorrect. You consider it by moving forward, is checking if the mass of 100 is being used, or the molar mass of 100 has been used. You further move with that answer that you get there to check now if the molar ratio or mole ratio is now given, and now furthermore with that answer, has it been used, then it basically says the learner will now only omit or lose a mark for the final answer. That is what now the arrows basically mean. Thank you very much for Mebusi. And 6.4, the question at 6.4 says, how will the volume you have calculated in question 6.3 change if now the 25 grams of pure calcium carbonate is used? So colleagues, remember, in this question we only used now 20.75 grams of pure copper calcium carbonate. So it basically says we are now going to have more of pure calcium carbonate to react. So the mere fact that we are going to increase now the mass of the pure calcium carbonate, it basically says we are going to have more particles that are going to react. And if we have more particles that are going to react, it basically says we are going to produce now more of carbon dioxide gas. That is the reason why here the answer now becomes increase for 1 mark. And the total mark for question 6 was 10 marks. Thank you, Mebusi. If there are any questions relating to question 6. Any questions relating to question 6? Mebusi? Okay, seems like I have lost Mebusi. Can somebody just check if I'm still audible enough? Maybe the problem is on my side and
Yes, you still are.
Nambane, I was sorry that I was disturbed quite a little bit, but
okay.
the problem is taken care of. So far, I don't see any questions, so I think we can continue.
Thank you very much, Mebusi. Let's go to question 7, colleagues. And question 7, 7.1, an organic acid consists of the following percentage composition: 39.9% of carbon, 6.67% of hydrogen, 5.53.4% of oxygen. Define the term empirical formula for 1 mark. So empirical formula, colleagues, it's 1 mark. The simplest whole number ratios of atoms, or ratio of atoms in a compound. So the key underlined words are there, but unfortunately on this one you cannot apply that marking criteria because it's only 1 mark. So this one you can basically say it's 1 or 0 with high level of confidence. There isn't anything in between, because it's just 1 mark. Then at 7.1.2, determine the molecular formula of the organic acid if the molar mass of the acid is 60 grams per mole. So colleagues, this was just 5 marks, and basically we wanted learners to give us the molecular formula of the organic compound. So check where the marks are. The marks are allocated at the far end of the calculations of the 3. So it basically says we need now to check if the learner has calculated the number of moles for carbon, hydrogen, and oxygen for all three colleagues. Is then that we can award this mark here. Immediately thereafter, step 2 is now to divide with the smallest to get the simplest ratio. The mark also, colleagues, check where it is sitting. It is for dividing throughout with the smallest number there, or the smallest number of moles. So we cannot award if the learner only calculated for carbon and not for hydrogen or oxygen. So the mark is sitting there at the end for the emphasis of calculating or dividing everything which is carbon, hydrogen, and oxygen. So be on the lookout for that, especially now the positioning of the ticks, because you cannot give for only calculating the number of moles of carbon, but the number of moles of carbon, hydrogen, and oxygen by dividing now with the smallest number for carbon, hydrogen, and oxygen. And now the mark is given for identifying the empirical formula. So for the empirical formula, we also have another mark there, colleagues. But now immediately thereafter, because the question was interested in the molecular formula, the other mark is sitting here after dividing the 60 with the molecular mass of the empirical formula. The last mark is for writing down the correct molecular formula. So this is now an easy way of marking it, and I believe we will not have much of the challenges here. So colleagues, most of you were unhappy with 7.2, but I believe our learners did attempt it well from what feedback I received immediately after the paper. So we still have another option that I'm going to add here on 7.2, but I will discuss it further with Mebusi. But it is an option that I feel we can also add for those learners that had a different thinking and still got to the final answer. So colleagues, expect that. But for now, I will just say this should be our option number 1, and we will share option number 2 later today once everything it's complete. So colleagues, here is the marking criteria. 1 mark for the formula of C is equals to N over V, and another mark now for substituting the concentration, which is 0.4 mole, and colleagues, and it must be with the volume, which is now 0.25 decimeter in that formula of C is equals to N over V. Immediately thereafter, it is now the use of mole ratio. It is now the use of mole ratio, and immediately thereafter substituting the 34 grams and N of XNO3 in this equation of N is equals to M over M. So colleagues, just check, it is just the number of moles together with the mass. The mark, it's not for the formula, but it's for substituting the 34 grams and XNO3, or the number of moles of XNO3 in the formula of N is equals to M over M. And now the final answer, which is now 170. I think this should be a comma, 170,62, that you can correct and check me on it, colleagues. So let's get into the question now that we have this marking criteria. So the question was saying an unknown salt XNO3 with a mass of 34 grams reacts completely with MgCl2 solution. The volume of MgCl2 solution is 25 centimeter cubed and its concentration is 0.4 mole per decimeter cubed. They react according to the following balanced equation, determined by means of calculations which metal is represented by X and for 6 marks. So colleagues, according to the marking criteria, this should be easy to mark. 1 mark for C is equals to N over V. The substitution now of 0.4 and 0.25 in terms of the correct SI unit for the volume. It gives us the number of moles of MgCl. The use, colleagues, of mole ratio. This is now the mole ratio. And immediately after the mole ratio, you continue marking as we explained in 6.3, the substitution of 34 and the number of moles, colleagues, of XNO3. So this is the number of moles of XNO3 and the mass. Then you calculate now the molar mass of X, and from the molar mass of X, colleagues, even if they do not have the SI unit for the molar mass of X, it is still fine. We can accept, because the critical thing here was for learners to identify the X. So even if they do not add here grams per mole, it is 100% okay with us, because the intention was now identifying that X is X is silver. So it can either be in terms of the name or just the formula. So that is how now the 6 mark is distributed. So colleagues, please feel free, because with stoichiometric calculation, there are always 2 or more options for one to go about this, but we try to compress the memo such that now you don't have so many options. But we feel that now we had, I think, about 2 or 3 options on this one on how to go about it, but those were taken out of the memo such that we do not have a huge memo, or we expected also inputs from you. So for the people that shared other options, thank you very much for that, and we will have definitely an errata for that. And colleagues, that was it with question 7, and the total now of question 7 was 12 marks. Mebusi.
Thank you, Mr. Nambane. No questions so far. I'm not sure. I heard you with 170.62. I'm not sure whether you corrected. I think you corrected it later. The 62, remember, is for the nitrate. Ne? So
Okay.
it's 170 minus 62.
62.
Colleagues, in case you missed what Mr. Nambane was trying to explain. 170 is for the whole X nitrate molecule. So the question wanted X, hence it is 170 minus 62, which the 62 is for the nitrate.
Thank you very
Thank
much,
you, colleagues. No questions that day.
Thank you. If there are no questions, then I can easily continue and go to question 8, which was the last question, colleagues, on acids and base. And we tried to ask the simplest, best possible way of acids and base for these learners to also expose them to the stoichiometric calculation, or how we prepare them for grade 12. So this is somehow the structure of the question we came
I
about.
don't see the question paper or the memo. I think your sharing somehow is affected.
Okay, let me go back. Sharing. I think it should be up.
Yes, we are okay now.
Thank you very much, Mebusi. A group of learners want to determine the mass of sodium hydroxide that is needed to neutralize 50 centimeter cubed of sulfuric acid solution with a concentration of 2 mol per decimeter cube. They use the apparatus shown on the right to do the titration between the two solutions. Write down the name of the item Z in the diagram. And item Z in the diagram, colleagues, it is just a burette, then 1 mark for that. Now, what is the color of bromothermal blue in a solution of sulfuric acid? So learners were expected to say yellow. And at 8.2.2, what is the color of bromothermal blue in sodium hydroxide? So the color is blue. So that is also 1 mark. And then now for 8.3, 12.5 centimeter cubed of sodium hydroxide is needed to neutralize the H2SO4. Write down the balanced chemical equation for this titration. So colleagues, we have a marking criteria here, and the marking criteria says you mark the reactants, you mark now the products, and the other mark is for balancing. It says ignore the double arrow and now apply the marking rule 6.3.10. What does this marking rule 6.3.10 says? It says, colleagues, before I can mark the reactants, there must be an arrow. So the arrow indicates the reactants and the products. So if the arrow is not there, I cannot continue marking or giving a mark for the reactant or giving a mark for the product. So the marking rule basically says if there is no arrow, or the arrow should be there for us now to start giving a mark for the reactants and also giving a mark for the products. And then the other mark is just to check if everything is balanced, then you give a mark for the balancing. So it's very important to check that. And also, colleagues, check the direction of the arrow of the learners. If the direction of the arrows it's not correct, it basically says then your products becomes reactants and your reactants becomes product. So just now check them on those, because it's the mistakes that they do. So in an essence, where it says now ignore the double arrows, so if they use double arrows, just ignore, colleagues, and that is for 3 marks. Now it says positive marking for
Sorry, Ngozi.
thank you,
Just in
Mebusi.
831. Nah?
Yes.
Yes. Remember the marking rule 6310, colleagues, says you can only mark reactants and products when there's an arrow. Now, say for instance, the learner in between the reactants and products gives a dash or an equal sign. Then we would still mark the reactants and the products, but we won't give the mark for the third mark, because now we are penalizing that is not necessarily an arrow, but it is an equal sign or a dash. So we will penalize for saying at least we can see reactants on the left, we can see products on the right, because there's a dash or an equal sign in between. But we will now penalize the third mark because there is a missing arrow there. In other words, the dash represents an arrow, but there's no head. So we are just penalizing the third mark. But if there is nothing in between, then the learner will get 0. And colleagues, don't forget, the third mark is for the twos. So if one of the twos is not there, then the third mark is gone. Thank you, Ngozi.
Thank you very much, Mebusi. Colleagues, let's get straight into it. At 8.32, it says now positive marking from 8.31. So it basically says the learner can now write an incorrect product, incorrect balancing, because now we need that balanced chemical equation in order to award a mark now for the ratio. So just check what is it that the learner has used, and remember you continue now marking with the mistake that the learner did. That is what it basically says when they say positive marking from 8.1. So the positive marking, colleagues, just check if the learner did not balance correctly, then it basically says the mole ratio that the learner is going to use is going to be incorrect. Then immediately thereafter, then just check what is it that the learner used. So we are trying to assist them to mark them with the mistakes that they have made. So here's the marking criteria. It is also 6 marks. And the first mark, it's on C is equals to N over V. And then mark number 2 is for substituting the concentration of 2 mole per decimeter cubed and the 0.05 decimeter cubed in that particular equation of C is equals to N over V. Then there's a mark for the formula, which is N is equals to M over M. And then now we have the use of mole ratio. This is the mole ratio that comes now from that balanced chemical equation. That is where now the positive marking comes from. Substitute now the 40 grams per mole in this formula of N is equals to M over M. And then now the final answer for the mass of sodium hydroxide, which is 8.888 grams. So colleagues, the marking of this should be easy. It's just 1 mark for C is equals to N over V. And remember the mark here is for 0.05 together with the concentration of 2. You get the final answer. And then now the other mark is for the use of the formula N is equals to M over M, and now the use of mole ratio to get that 0.2, hence the mark it's on the 0.2. And now the other mark is for substituting the 40 grams per mole in the very same equation, hence we have our 40 grams there, and the final answer, which becomes 8 grams. Colleagues, so feel free to send any other options to your subject advisors. I also have another one that I will want to share here, but the approach is basically the same. So the total of question 8 was 12 marks, and from me to you, thank you very much for assisting Mebusi. Any other logistics, we will attend to them as soon as you are doing the closing remarks. I will send the register and everything in the chat, because that is what now I have. So colleagues, from me, thank you very much, and I am handing over to Mebusi.
Colleagues, good day once again. Thank you very much for your contributions. Thank you very much for the time you took to be with us for this memo discussion. Remember, we always say be with us so that we correct the mistakes with you, so that we give you other options, so that you can also contribute in terms of giving us other options that are there. And it is important for us to be in this memo discussion because we want the entire Free State to mark in the same way. By the way, we are preparing these learners for grade 12. So we want the marking in grade 10 and 11 be the same as the marking in grade 12. So colleagues, we will get back to you with the addendum in the questions that we said we'll discuss later. So just keep an eye on your WhatsApp groups with your subject advisors, because the addendum will be sent there. With the other options, colleagues, also, if you have any options or any questions, still ensure that you ask your subject advisors. Thank you very much, colleagues. Have a great day. And if we don't see each other anytime this year, have a Merry Christmas and a prosperous New Year. Thank your family again for us, because you've been working very hard for the entire year. And sometimes you've been taking the time for your family to work for these learners. So thank them for as well, as I'm also thanking your colleagues for working hard for the future of our learners. Thank you very much. May the good Lord bless you. Goodbye, colleagues.
Thank you, Mebusi. Before you leave, colleagues, let me just quickly chip in. Thank you very much, Mebusi, for those kind words. The streaming is available on YouTube, colleagues, for those that did not manage to get. But I think it's going to be in two parts because of that breakdown we had. But that is not a problem at all. I did record the video, so I think I will upload that video to the YouTube as well. The link will be shared later today with the subject advisors. Kindly fill in the register, colleagues. It is the only proof that you did attend this particular meeting. So without wasting any time, maybe see, thank you very much for assisting me, because I had now to juggle between the recording, the presenting, and the live streaming to YouTube. So you made it possible for me. So colleagues, from me to you, thank you very much, and may the great Lord bless you and give you everything that you desire. So let's meet soon and keep well. Thank you very much.
Dr. Nambane,
Okay.
my apologies, sir. How do we get access to paper 2 memo? I still don't have it.
I will send the link also that to our cloud, where you will be able to download, say. Just be on the lookout for that message.
Yeah, on the cloud, is it the one you're talking about?
No, sir, we have our own independent cloud that is governed by Ntate Velman. So I will send it to that, not the HW Science.
I have no idea about that, not even the access, sir. I would humbly request if you can also avail the access to that cloud.
I will definitely do so, sir. Don't worry. It will be shared with your subject advisors.
Thank you, sir.
Thank you very much. Any other clarity-seeking questions, colleagues? Then we can close the meeting. If there isn't anything, colleagues, thank you very much, and all the best with marking. Let's meet again very soon.